Good evening, everyone. In this lecture video, we're going to discuss the CP scheduling. First scheduling is FCF first scheduling. In that, have in the previous lecture we have discussed what is waiting time, what is turnaround time, and things. How we will calculate the waiting time for the process. In the waiting time equal to we have to start time minus arrival time. Suppose process P1 the arrival time will be 0, and start time we have to calculate the waiting time. The start time minus arrival time. Turnaround time will be calculated by total waiting time plus burst time. We can add, we can get the turnaround time. Then Gantt chart, FCFS scheduling. Look at the screen. We can able to see the process ID P1, P2 up to 5 number of process. So we have arrival time of 460,605. In the burst time we have the some value, or each process we have the different values. So Gantt chart P3, P1, P5, P2 and P4. So process ID P1, P2, P3, P4, P5. In this completion time and turnaround time, waiting time we have to calculate. The shaded box represents the ideal time of the CPU. Suppose the P3 completed, the P1 will be started, the process request will be sent to the CPU. The request not accepted by the CPU. Then the Gantt chart, the color shaded box represents the ideal time of CPU. Until the request received from the things cannot be reached. So P3, P1, P5, P2 and P4. So for example, completion time 1917, 3 and 1915. So turnaround time will be calculated based upon the things. So based in this shaded box represent the time of CPU. Ideal CPU will be ideal for some time of milliseconds. It will be ideal. P3 will complete it, and the P1 start will be it takes time. So in this things, turnaround time we can calculate it using the completion time and burst time on arrival time. So turnaround time we have the formula as waiting time plus burst time. So waiting time plus burst time we have the 9 is the completion time, is the burst total time, and 4 is the P1 have the arrival time of 4. So 9 plus minus 4 we have the 5 is the turnaround time, and waiting time equal to formula we have waiting time equal to starting time minus arrival time. So starting time for V is 5 minus 5 equal to 0. So that is the value here. So from process P1, P2, P3, P4, P5 we have the 5, 11, 3 and 18 we have the examples. So we have, so from this average turnaround time 5 plus we have the 5 process, we have the average of 8 units. We have the total average turnaround time will be 8 units. Then average waiting time will be 4.4 units. In this video we have a better understanding of CFS scheduling. Next we have the shortest job first scheduling. In this shortest job first scheduling we have the algorithm associated with each process, the length of its next CPU will be burst. Use of this length to schedule the process with the shortest time. So SJF is optimal. It gives a minimal average time for a given set of process. The difficulty is knowing the length of the next CPU request. So process P1, P2, P3, P4 and burst time will be 6, 8, 7, 3. So SJF chart we have the average waiting time equal to 3 plus 16 plus 9 plus 0, so equal to 7. So average turnaround time will be a change here. So according to the SJF scheduling, the shortest job for scheduling, in this primitive SJF and non-primitive SJF, primitive is version is called shortest remaining time first. So process P1, P2, P3, P4 arrival time will be 0, 1, 2, 3. Burst time will be 8, 4, 9, 5. So primitive SJF Gantt chart will be P1, P2, P3, P4 and P1 and P3. The average waiting time will equal to 10 minus 1, and I have the average 6.5 millisecond we can get it from the above example. So priority scheduling is the next thing. We have the priority scheduling is important algorithm used to which process will be give the more priority. So is associated with each process. CP is allocated to the process with the highest priority. Smallest integer equal to highest priority. There are types of primitive but non-primitive. 2 types of priority scheduling having. Then SJF is the priority scheduling where the priority CPU burst time we can have. So problem equal to starvation minus things. So solution equal to aging minus things. So non-primitive, we have the example of P1, P2, P3, P4, P5, P6. So burst time will be 10, 1, 2 and 1, 5. So priority, in the periodic scheduling Gantt chart, we have the P02, P5, P1, P3, P4. So 0 to 1 and 1 to 6 and 6 to 16 and 16 to 18, we have the priority of P4. So average waiting time for this above priority scheduling, we can have the 8.2 milliseconds. So in this primitive or non-primitive, so primitive we have P1, P2, P3, P4. Arrival time will be 0, 1, 2, 3. Burst time will be 8, 4, 9, 5. So priority will be 3, 1, 4, 2. So average waiting time equal to 6.5 milliseconds. And primitive and non-primitive, we can have these kinds of process here. So round robin, before going to start the round robin scheduling, we have the in this lecture video we have discussed what is FCFS continuous and what is priority scheduling, what is SJF. So thanks for watching. We can continue the CPU scheduling, remaining scheduling algorithm next video. Hope you all understand what is FCFS and SJF and the priority scheduling algorithm and primitive SJF. Thanks for watching. Thank you all.